Hello, welcome to your section 1-4 notes, measuring angles. Again, we'll start with some vocabulary. Angle is just two rays with the same end point, and the vertex is that end point. Everybody has seen angles before. Now it comes to how to name them. So you can name them three ways. You can name an angle by a vertex, but only if it's a very simple angle like this one. I can call this angle O because that is the only angle in this figure that has O as a vertex. I can also name by a point on each ray and the vertex, and this is what I would have to do in this figure here, remembering that the vertex point must be in the middle. If I look at point X is the vertex for a lot of angles. So angle QXR is this one right here. Angle XST is this one right here. Angle RXT is this whole thing right here. ABC is this whole thing right here. But I can't just name an angle with a single letter in this figure because there's too much going on at every point that would be the vertex. Again, I can't just call something angle X because which one would I be talking about? There's a whole bunch. Same with B, even though it's a little simpler, I could be talking about angle ABC, I could be talking about angle CBX, I could be talking about ABS, this straight angle right here. So I have to name it by three letters and making sure that the vertex letter is in the middle of the name. I could also name it with a number if I were given that. So I could call this angle 1. So QXR can also be called angle 1. RXS can also be called angle 2. And XST can also be called angle 3. The protractor postulate is pretty similar to when we were talking about the segments getting their length on a number line. If you were to be measuring an angle with the protractor, you would just look at the number the two different rays were pointing at, subtract, and take the absolute value. Because just like length, a degree measure can't be negative in the figures that we're working with. 4 types of angles, which I'm sure you've heard of before. Acute is less than 90 degrees. Right is exactly 90 degrees. Obtuse is more than 90 but less than 180. And your straight angle is 180 degrees. So again, QXT would be an example of a straight angle. It's 180 degrees, and we're going to actually use that idea quite a bit coming up. Congruent angles are just angles that have the same measure, so they're equal. And then the angle addition postulate is pretty similar to the segment addition postulate. If B is interior of angle AOC, then the measure of angle AOB plus the measure of BOC equals the measure of AOC. Again, kind of a fancy way of saying little piece plus little piece equals the whole thing. If anything is sectioned off, all of the sections obviously have to add up to the total. So a few examples based on that information. Here's my figure. If I'm going to name angle 3 in 2 different ways, well, here's angle 3, so it's this right here. I could name that BEG or GEB. The order doesn't matter as long as the vertex E is in the middle. Angle 7 in 2 different ways, same idea, GET or TEG. It's the same angle, E was in the middle, so that has to be in the middle of the name. Looking at different angles, I know that GET would be an acute angle because its measure is less than 90. BET would be a right angle because it's exactly 90, and I knew that it was exactly 90 because it came marked on the figure here. So since this is a straight line, if this side is 90, that side also has to be 90. LEG, I'm just following the letters to know what angle that is. LEG is this whole thing right here. That's greater than 90, that's why it's obtuse. And LET, again, is just that straight angle, so it's 180 degrees. One thing that I start to notice people making mistakes on, especially as we start to use this in proofs coming up in chapter 2, straight angles are 180 degrees. segments are not 180 degrees long, or they're not 180 units long. So that number 180 just goes with angles. Okay, looking at a little bit more complex figure. Okay, you're always going to want to look for markings, any relationships you know, because no matter what, you need a place to start. Okay, so I'm going to kind of look at this, and if I look at what I'm given, I was given this 90-degree angle box, so I know this angle right in here is 90 degrees. I don't yet know how much each part is, but I know the whole thing is 90. I also know I have 180 degrees because I have a straight angle right there. So before I get into this, again, I'm always looking for a combination of things. What information was I given that I can use? And what kind of an equation can I build that only uses one variable? Because again, I cannot solve an equation that has two different variables. So when I looked at the information that I had to start with, I know this is 90. The two sections that made up that 90 degrees both use the letter X. So I was in good shape. So again, I'm given a total, so I use the angle addition postulate. This piece plus this piece equals the whole thing. So x plus 6 plus 5x equals 90. And I had that. When I worked my way through it algebraically, I got x to be 14. Now what I think is helpful is as I go along, I try to fill in these degree measures because I never know if I'm going to need to use a number for something. So if x is 14, 14 plus 6 is 20. And x right here, if x is 14, then 5 times x is 70. So I may as well just mark that down so that I have it in case I need it. Now I'm going to look for the value of y. There are two different ways that I could look at this. If I know this whole section is 90, I would know the rest of that straight line would have to be 90 as well, because it all has to equal 180. So I could set it up that I know this section, 7y plus 4, plus this section, 2y minus 4, equals that leftover 90 degrees. I'd work through that algebraically and I would get y equals 10. Or if my eye is kind of catching that I have a straight angle right here, I can set everything equal to 180. I just have to remember that everything adds to 180. So I would do 7y plus 4, this section, plus 90. I still have to include this section, plus 2y minus 4, this section. The whole thing equals 180. And again, I keep doing this because I also know that a semicircle is 180 degrees, and that's how I know that everything on there. I'm still going to get y equals 10. The mistake many people will make is 7y plus 4 plus 2y minus 4 equals 180, because they see that they're on the same line, but being on the same line is not the same as you have enough to make this whole line. So that's why this middle section had to be included. And once I know that y is 10, I'm going to know that this section is 74, because 7 times 10 is 70 plus 4. And then 2 times 10 is 20 minus 4 is 16. And again, I should be able to add all that up and end up right back at 180. So now to figure everything out, I'm just following the letters. So the measure of angle NSG was 20. The measure of angle ASN, that's this, 74. I'm going to put my little degree signs. The measure of angle GSL, that's this right in here, so that's 70 degrees. The measure of angle LSE, again, that's this right here, 16 degrees. The measure of angle ASL, ASL. That's this whole thing here. So that's 74 plus 20 plus 70, that's 164 degrees. The measure of angle NSE, NSE, again, I'm following the letters, that's everything in here. So 20 plus 70 plus 16 is 106. So again, I started with the information that I had, which is I knew 2 of these sections added up to be 90 degrees. Solved for that variable, plugged it in, found a degree measure. Y was only a little bit more complicated because I had to remember that I still have to account for the fact that this straight angle here is 180 degrees. So I could do it 2 different ways, but either way I should have gotten y equals 10, substitute that in so that I have degrees. And then anything that was a little bit bigger or that involved more than one of these angles, I could just take all those degree measures and add them together. So that's it, and I'll see you in the next section.